So mic check, yeah, it's working. All right. So of course, every time you, just like John just said, and earlier also Tony, you think about when you come here. Okay, what does this topic mean to me? You know, where do I see a relationship? And actually, I was really thinking when I was making my slides. Oh, these slides look really, really simple. Perhaps it might not look as advanced as, for example, the presentation of John we just had. And then I thought, well, how old are these slides? Some of them are 6 years old. So that means they survived 6 years of politics within our organization, and they're still on top. That's pretty cool. Change management is very hard in those things, and also with risk management, drilling it down to something really simple. And this also made me think even now about the daily life example. I used to work for Mammoth, so not the tiniest chips in the world, but the biggest cranes in the world. And when I was in Canada, I was sent straight on to a course for 2 weeks with the government about safety. If you're a manager there and you screw up, you first go to jail and then you can prove your way out. And so, you know, you better get some good training in there and you really get the law and you have to read through it, which are things like how far you have to be from an electricity wire, etc., etc. So after these 2 weeks, actually really something clicked. I started really thinking differently. I had to go to the IKEA to buy my furniture, and all of a sudden I saw there was no instruction on safety on how to lift those packages of 50 kilograms, which is weird, right? So you really start seeing things when you start understanding things. And that's also really what is tricky about FMEAs, etc. So not everybody in your company will be able to do an FMEA or understand it into depth. So how do you bring it back to a level how do you bring your culture back to a level where everybody understands that risks and mitigation of risks and complexities are very hard to understand, but that you escalate it straight to the right person? And this is what I want to be talking to you about today. So how to use risk management also to create value for yourself and for your customer, not just to prevent, but to really start creating value. And before I do that, I just want to gauge a bit what is the audience here. So how much I'm, you know, sort of, I'm not a mechanical engineer or anything. So, you know, I just want to know. So who, show of hands, is here engaged with quality? So quality management. Okay, oh, that's a lot, okay. Who are in engineering? Anybody? Oh, that's the other half, it seems. Anybody from production? Okay. That's actually where the quality happens, right? Sales, business development. Okay, yeah, all right, good. Did I forget anybody without screaming titles? No? Oh, that's pretty good. All right, so first question I have, was anybody of you ever engaged in the fallout or clearing out an AD or a big escalation within your company or thanks to your supplier? Anybody? Yeah, there you go. And then from now on, every time we must and we shall always do full documentation, FMEAs and everything. And then the next week somebody says, well, for this project, we can't because it's too, you know, we can't because we don't have time. Anybody had that ever happen? Yeah, some. All right. Question number 4. Has a customer ever asked, could you please give me a price next week on this product design? Oh, no, sorry, I don't have the final TPD or documentation ready. Suppliers, only 1. Oh, we have that a lot. And then the last one, you just spent 2 hours in a meeting with 7 people discussing why you have to do an FMEA or not, and then you really think, I should have called my buddy from production. We could have made in 7 hours with the 2 of us a full FMEA and actually discovered all the risks. Anybody did that? Oh, yeah, there you go. Oh, nice. All right, so you know, these are not just questions, but also things that we struggled with. Which projects you use a full risk assessment, which not? Who should you involve? Who should you not involve? How can you get out of endless discussions and really, you know, get going as quick as possible? So thanks for your feedback. And now, seeing from the engineering, quality management, and production, I will keep it as technical as possible. All right, so if you don't know who we are, so we're Erics, and what we basically do is we support all industries. Yeah, we could have set a scope, but we went for all. So we really supply a lot of components to various different industries. which is actually really good. We learned actually a lot from HVAC, which we are now applying in semicon. So actually doing business with different industries can really learn you a lot. We have very many different types of products. So we can go from engineered plastics to power transmission, sealing, and these can range from standard A brand products to our own brand products, or even to fully customized products. And we do this with a lot of passion. We have a lot of specialism on these specific ranges, and we try to be ahead of the curve. So where we're not just brokering supply and demand, we're really trying to come up with new materials, come up with new ways to solve things. But this also creates a little bit of a dilemma. If you do so much for all industries, how are you going to implement a risk management philosophy or strategy and create value for all those customers? Well, it even gets worse. We have over 1 million products, of which many are customer specific. We have more than 4,000 customers, 400 large ones. Well, we say large ones, and we get thousands of questions per day. We want to, of course, deliver on time in full, OTIF, according to the specs, high quality, and compliant. So yeah, what we really started seeing is implementing risk strategy is not only about doing it reactively, but also really proactively, and then really create value for our customers. So this is our dilemma. I hope you can keep that always in your mind when you see simple pictures from our side. Oh yeah, this is really practical if you have to deal with 1 million products. All right, so it all started with, making different models, making different designs. How could we start dealing with making sure that we would always sort of be on par? So if there's a very risky project, that we do all the risk assessments and that we're aware that it's a risky project, or if it's a very simple thing and it's actually an A brand product, that we can rely on them, for example. So we started first on the reactive side, and here we also had some help from Holland Innovative. This is actually a slide that comes from the Master Black Belt course. This is the magic triangle where everything starts at the base with quality. If you focus on quality, this could be quality of a product, but also quality of people, quality of procedures, etc., etc., etc. If you focus on quality, you'll get dependability, and if you get dependability, you'll be able to do speed. So in our case, that would, for example, be if you know that each product that you make in your own production takes you 3 days, you basically can set the delivery day at 4 days, because you can then have another day for UPS to do the rest. Because it's dependable, you can be speedy, and because you can be speedy, you can be very flexible, because this product is only needed 2 weeks from now, so I can do another product right now. Flexibility, often called agility. So if you ever hear somebody speak about we have to be agile, you just say first go to quality, and then eventually you can even be very cost effective, because if you are so good at moving flexibly with what you deliver, you actually have a very high utilization of all the assets, all your people, and all the things that you have within your company. So we really started looking at how can you start decreasing failure costs, so really understanding where it goes wrong, and eventually you hope to see that you can start increasing opportunity, creating value for yourself and your customers at the same time. The second building block that we, of course, started using was Design for Six Sigma. So we had Lean Six Sigma after the fact, and we thought, hey, how about starting to build this into our designs? A classic project is the yellow line. We misunderstood complexity here. Scope creep gets even more tough, more people involved, more complexity because more people are involved. Everybody happy at the launch, but we're still, investing a lot of energy at the back there because, well, yeah, we overlooked something, one of those 40 factors, right? So you want to do that up front, but how are you going to then gauge the complexity here at the front of this curve? So that became really the next question. Well, the obvious answer is, of course, make very big lists with all the risks that could be in a project, all the stuff that needs to be done. So if a customer asks you a question, you just hammer them with huge lists of questions about whatever, is needed. You do that 1 week and then you find that it's not fast enough, or, So also many questions, but which of these questions will jeopardize a first time right delivery, right? So again, very tricky. So we started making models and making different levels, and somewhere Christmas 6 years ago, I was sitting with somebody from procurement, Johan, and we were really thinking about, so what are now these main drivers for us that make it very complex, but also for our suppliers. So because we were of course in the middle, sometimes we produce ourselves, sometimes we do it together with our suppliers. And what we started noticing is that actually we could condense it down to 2 axes. So we have the axis of complexity coming from the customer or the contract. And these could include things like, what type of business is it? Is it MRO, OEM type of business? Is it a certain segment? Is there a contract in place with very strict mandates on, for example, could be insurances or delivery on time. This makes it very complex to deal with customers, for example. Also very important when it says segment. Sometimes you can think, well, this is a big customer, I have a contract in place, but then there's a subcontractor from them and they are new, small business, new to the business, and they come to us and they say, hey, we have this design for you. We're not telling who it is for because of course they're, you know, scared to get out of the middle. And but it's for semicon. It's like, it's for semicon. If you know that, you also know that somewhere down the line, even they're not asking it at day number 1, they're going to ask for an FMAE CPK. They're going to ask all these other things that they didn't include at the start. So actually adding in the industry, for example, if you know it's automotive, you know you will have a PPAP somewhere down the line. So knowing this is super important to understand and gauge how tough of a customer it will be from the contractual side and all the things that you have to deliver with your product. Now, the second axis that we really saw was the complexity of the product itself. So we just mapped it 1 to 5, very easy. But this could be things like geometrics, tolerances, how long it should survive, what medium goes through it, norms and standards. This could be anything. And what we really try to do is condense it into this simple graph. And there you actually see, if you start combining these in the upper right corner, you will end up, if you come to Eric's, in an engineering team handling it. Then we have technical sales and customization. And then you will have sales in the sales and offline, online sales, where it's more commodity, and catalog products in the left undercorner. So a few things that I want to say about this. Earlier you saw that we have 8 different big groups of products. So why is this picture important to us at Eric's? Is because it makes it possible for different business units to talk to each other. Because behind this is actually our huge Excels, and we go with different teams, we go through exploring what is complex to them. So these are of course relative numbers, right? So we for example say to precision motion control, what's an easy product for you? That might be, I just buy and sell an electric motor. But here it might be a combination of the electric motor with some PCB, and also some programming that had to be done and some life cycle testing that had to be done. So it's way, way more complex. And this is how we gauge with the different teams what are very difficult customers, contracts, and segments for them, and what are, relatively speaking, very difficult products for them. And in this way, we have different people from the whole business unit engaged in this process of understanding what is complex. And then the second question we always get is, so what's the difference between an A1 and an A2 project, right? It goes to a different team, but actually, how do you make sure that everything is mapped perfectly? So here's a nice 80-20 one. So what we noticed actually from escalations was that when it goes wrong, you end up having a product that was designed to take part, let's say, in the left under corner by a supplier who was the last one who wanted to make it, and it is their scope creep. And by the end of the project, you end up having a super high-tech, very difficult contract where you need to abide by. And then you can say, well, Eric, you're in the middle, that's your problem, right? But no, it's not only our problem, because, as a collective, as a whole supply chain, you're not going to make that work. So we noticed that making sure that it falls into the right team, or that you have a nice discussion whether it should be an A1 or A2, or having a B2 or a B3, these discussions actually help internally with people understanding what the complexity of this project is, and actually understanding what should be done, which team it should go to, and who should handle it. So behind this, the picture itself makes it possible for different business units to work together. And also, it's a very nice picture to also think about if you see scope creep, hey, by the way, we might be having to do some additional stuff here. All right, so these become our inputs. So the complexity of the contract, complexity of the product, and it determines a lot. So it determines what team should be involved, which specialists should be involved, how the routing would be through the company, or the speed, right? So a sales, a commodity that's in stock or a catalog product that we pre-designed, of course you can ship it the next day, but that doesn't count for very high-tech stuff. You have to go through validations and release processes. So the speed also varies. It also varies what process we use. For example, for engineer products, we use Design for Six Sigma, and also our engineers are either trained or going through training. It can really change your supplier choice or which element within Eric. So we have different production facilities where we will produce it, close to the clean room or not, in the clean or not. Also how we audit them, contract them, how we deal with quality management. Will we have a very big protocol connected to the product for incoming and outgoing, or is there full traceability within the plant? And then some additionals like, does it have to be routed through the clean room? How do you deal with time, tooling, and for example, insurances? So it has quite some impact. And if you look at escalations, again, back retrospectively, you will see that, oh yeah, we did see that it's an engineering project, but we handled it in the right team, but with the wrong process. Or you will see that there's no line of thought that is completely straight. So we started connected even more and even more. So we started mapping who should be in the lead, which team, but also who should sign off based upon the complexity, based on sign authorities. Suppliers, we started connecting to supplier selector tools where we started dubbing them strategic, preferred, or just an alternative supplier. And step by step by step, we started implementing this also in our stage gating. So this is all reactive, and step by step by step, we started moving forward. So actually in the stage gate 1, where we have, for example, our application engineers bring in a new opportunity, we'll start assessing the attractiveness. So yes, lots of money, lots of margin, awesome. That's how it used to be, but also the complexity and actually the capacity of, for example, your engineering teams, or for example, of your production to, of course, have OTIF in the end. But is this proactive enough? So I think what I've told till now is a journey of about 3 years. And we started ingraining this in the teams. It takes a lot of time to get everybody engaged because, of course, it's not their daily job. Their daily job is to make products, and or to sell them. So can we even take it a step further and be even more proactive about it? So that's the final slide I want to be talking to you about. So one of the things that we did is we started really thinking, if we would synthesize on those million products again, on all those customers, on all those different segments, what are typical risks that we see in these different layers of the company, right? So what are typical risks we would be facing in catalog type of products, customized products, and engineered products? And here, for example, you see very interesting stuff like you want to have, for example, with typical risks, suppliers are a big risk, or your own production as well, if you look at engineered products, because they need to also adhere to all these rules and standards, but also because you spend so much time making this together, you have immediate lock-in. So, you're in the middle sometimes as Eric's, and that can really, get quite uncomfortable if, for example, they can just double the price, and then what happens, right? So how do you deal with costs and amortization of costs, right? So such expensive development trajectories, some people just want it for a dime, right? So or they will even take our ideas and designs and they will just benchmark us against others again. So these are typical risks that, for example, happen there. But here at the catalog, one of the things here is that how do you do a proper assortment management, and that you're aware of the whole assortment and what the quality is of that assortment, What's the base level of quality that you want to be going at? Do you want drawings of all these million parts, or can you also refer to, for example, databases? So for each of them, we started mapping typical risks, and then we started thinking about what's the associated way of working, what would really work well there. And for example, for engineer products, we really chose for Design for Six Sigma, having engineering departments with their dedicated team leaders, going through green belt trainings, and really getting up to the level of where, even though it might not be necessary, we either comply or conform to an IATF, so automotive type of standard. Again, why? Because people might not be aware of the risks that they don't see because they don't understand them. So you can better be smart about thinking ahead about that in such a process, and you have time for that, so that you make sure that you catch it before it happens. Yeah, and then we connected that eventually to first-time right strategies. Well, first-time right strategies at the top there is, yeah, engineering is a human business. It is dependent on the skill of and the thought process of everybody, what you're going to get out. But for example, in customized products and in catalog products, the speed makes it sometimes impossible to have such a thorough thought process, right? So there you need to start thinking about how can I, for example, standardize that here or make it into modules. So a typical customization project would be, let's just say you have a hose, and normally it has two ends of that hose, which you can configure in configurators, but then all of a sudden you want to have a different valve at one end. What you don't want to have is that there's 100 suppliers of different types of valves out there, and you just say, we can connect anything. Well, you could, but you end up with a whole lot of risk and a whole lot of dealing with 100 extra suppliers, which might phase out these, these valves, and it's impossible to manage. So there you have to really start thinking modular. Thinking modular from the fact of that certain types of things can be added at the end, but also, for example, thinking really differently about how you would engage with an FMAE. So instead of, for example, doing FMAE on each of the products that you design, you can also think about doing more FMAEs on all the stations such a project might go through, so that when you go and make these products, you actually be much faster and you know a lot of risks up front. So indeed, these are strategies that we really use now or are exploring and engaging with to basically root out risks up front in the design already, for example, using design automation, where you have two different parts and you start connecting them automatically in the design process. Another way we did it is that, well, we can map ourselves what we find complex and how we deal with contracts, but this is of course a back-to-back risk. So if we do it ourselves in our own production, we could map ourselves as a production specialist. Where would we be? How good is our production in a certain country or in a certain place within ERIX to deal with contracts and very complex documentation, as well as deal with the very complexities of the product itself. The same counts for all your suppliers. So this became also a model for us to proactively engage with our suppliers. And for example, this one and this one are a bit scary. The coloring, well, I'm not going to explain exactly what the difference is between coloring, because it's, it goes into a kind of a little bit of IP, but it means something like the products are either used strategically or there's a lot of money involved. So this might be a big supplier to us. And this gets really scary. So let's just say this is a big one from money perspective. Here you see that they might be very good at difficult products, but they're super bad at the contract. They might not even want to have a contract. So here's quite a big risk for us. So there's two options then. What we can do is we can either start trying to develop them. Well, if you have so many suppliers, developing your suppliers is really hard. So you might sort of start proactively thinking about replacing the articles or the assemblies or the parts that they're delivering to you and changing that over to one that is, for example, W, what might be a good candidate there, if it's, for example, for semicon. So if there's parts in here, that I'm not saying it is, but so that's also a way of looking at your suppliers. Same counts for number P. Still, that is a strategic project product is combined there. And the thing is that you can of course ask, so how did it end up there? Well, it ends up there because everybody's just, trying to do and serve this customer, right? So you have a question, oh, I can get that by that supplier. And you're not completely aware of all the risks that you're taking on along the way. And this is the thing why these type of graphs are really helping us, making sure that we, on a very holistic basis, start to see and map what is the residual risk that we have. And then the last thing, as I said before, first-time right projects are a win-win for both us and our customer, or customer and us, depends on where you're thinking from. So how could we even take it a step further to be even proactive about first-time right? So that's what we really started to do also, is that we start to have internal discussions about what are we really good at? What are really our core competences? What are really the projects where we excel? And what you will see in opportunistic conversation, well, we're very good at complex projects. Yeah, you're really? The most complex ones? Do we really want to have only very, very complex long ones? Or do we want to have a mix? Oh, okay. And so you start seeing the attractiveness, how close it is to your core competences, what you actually can develop, associated technical roadmaps with that, how it interacts with the complexity of the product. And of course, very simple. I mean, if your engineering team is full with very fancy, complex projects, you can say that you can take on another one, but you know how that goes, right? So if, somebody pushes another project from the table and you're not going to get your OTIF score everywhere. So balancing this and knowing very proactively what you can take on and actually going out there and searching for these type of projects is very important, because what we've noticed is that if you finish a project and you did well, you'll just get the next one. It sounds a bit quirky perhaps, but making sure that you really do first-time right job actually gets you the retention. So yeah, and that's a very big journey that we took from just being reactive, not understanding our risks at all, step by step, moving it into a strategy where we started routing it, putting it all the way at the front, and then step by step, taking it as far as that we're even searching out now the projects that we really want to have. So that's it. And I'm actually very short on time.
You're very well on time. So
yeah.
I am sure we have some questions here in the audience for Job today. Who wants to go first? Yes. Do we have a mic? People with a mic? Or do we do it via... I see someone pointing. I see waving. I see... Oh, we have a mic here? Well, this one is closed. Here's... Yeah?
Okay.
Oh. You okay?
Okay, yeah, I'm going.
Okay.
You're talking about a lot of proactive, and as you are a supplier to end manufacturers. Proactive is also about chasing your customers about problems they observe from your products on the field. How do you do that?
Oh, that's a very good one. Actually, it should be added to the roadmap, I have to be honest. Of course, I mean, you have end of life where you can proactively do that. I do remember a lot of cases where you have an escalation and you actually say like, look, there's a faulty design here. And that's actually really tricky for us. So we are, in Dutch you would say, we hebben niet zoveel in de pap te brokkelen. So it is quite tough for us to change something. So I'm not talking about customers in this room now, but I can assure you we had some customers where we cannot convince the designing department of that customer that after an escalation, they just want to see still that we do quality checks on the product. Even I make the gesture of the quality check that we do. Hilarious. We've been standing pulling strings like a long time, I assure you. They just didn't want to change. And that's really hard for us. So, and the same counts, I mean, there must be a lot of ASML people in here. Changing in TPD after the fact is close to impossible. And that's also not where the focus is. So that's really tough for us. So I think that's definitely something to look at more, and also to showcase what the risk actually is, so that you give them, and you know, it's up to them to decide, but that you really show like, hey, there's a lot of residual risk here you might not be aware of. So I think it's a very valid question. Thanks.
Okay, thanks. Do we have another question? I saw someone up there raising their hand. No, had the same question? Here, a question up front.
So I saw the guy in the clean room suit, but
Yeah.
he wasn't wearing a face mask. Why is that?
Probably pre-COVID. I don't know.
I have a question. Yeah.
Yeah, I saw a lot of things focusing on quality. How at Erics is that embedded in your learning organization? Because I think people should learn a lot before they can actually apply it.
Yeah, so we started, I think 5 years ago now with this. So we started first with Lean Six Sigma. So we had, and you have to imagine that, I mean, we don't have a whole 1,300 or was it 13,000 university graduate engineers in. So that group that pool is quite small. So we started with Lean Six Sigma, really learning about that, and that actually was typically Erics. I went to a director and I said, I need 25,000 euros, and I will save you 250,000 euros in risk decline, and I will train 10 people. And that's how it started. That became a program, and that really worked. Then we really saw, so after the fact is perhaps good, but before the fact is even better. So then we started with the Design for Sigma program, first joining Holland Innovative's general classes, sending some people out and say like, hey, you just go there, see what it is, and if not, you just sit with some very smart people in the room, which might be customers, so, you know, there's always a plus. So that even became a program, and now we do, we train about 20 engineers every year. Again, this sounds for perhaps ASML not a lot. We are with 5,000, and we have about 250 dedicated engineers in the engineering team, and we have now trained close to half to a green belt level. Some of them went to the FMAE facilitators training, and we're now also the first ones going to reliability, because we really see there also that reliability helps with, for example, questions that we get now about sustainability, where people say like, hey, you know, I have this product, it needs to survive 7 years, but it is very pollutant. What else do you have? And then we can use our material models and change that. But it's a journey. When I came in, I had just a pile of escalations on my desk, sorted out job for sales. And so, yeah, so, and now it's really ingrained. So we have engineering days, and yeah, it's not as formal perhaps as you might, but it's, I think also formalizing it is both good, but at the same time has a risk because it needs to come from within. There are some people from Erics here in the room, and they were very heavily engaged, for example. So the engineers themselves were doing the trainings to their fellow colleagues of sales about the complexity matrix, because the answer of what projects should go to their team is also the answer to which projects should not. And having that conversation and training people that are peers of you, but perhaps in a different function, is very strong. If I just come in and do a top-down story, it doesn't work. So, yeah. Thank you.
Makes sense. I see we have a question in the back as well. While the microphone moves over there, the online people can also ask questions. Do we have any questions?
This is where you can't do an FMAE on all the questions that you get, huh?
Yeah, no,
Yeah.
no. Final question then in the back.
You said something about that was very difficult to have TPDs changed after closure, right?
Yeah.
Yeah. But it also means that the design phase is kind of closed at that moment. So how does that resonate with being proactive then?
Yeah, so it's a very good point. We are luckily in the position where, because we were proactive about, for example, engineering our own materials, engineering our own knowledge on what might be needed a few years from now. For example, vibration damping has become a very big issue in the new machines. So we already went out and designed vacuum grade materials that are very good for vibration damping. So you get a complete different seat at the table. So you will be asked, can you review this design? You might not get the DFMEA, but you know, they will ask, and it's not anymore a question of build to print, but it becomes really a question of what can we do here, and can we design things. So we're getting more and more engaged in the early stage projects, and that really helps us to get to a TPD that actually we know for sure that can be Six Sigma supplied. Yeah.
Relook your previous design maybe because of that new or change.
I'm sorry, I can't hear you. I'm very sorry.
Do we have the mic still there?
Excuse me.
No worries.
Yeah.
So it means like for each new order or new project, you have to reassess your existing design maybe for the new requirements then, basically.
It's hard. It's on the high end, very much engineered projects. We are very lucky that we have engineers that we send out. So we have application engineers. We don't send salespeople to our technical customers. So, and that already makes that we are sitting more as a peer on the table and really say like, hey, this is new in our toolbox. Perhaps we can do something with that. And then you get more a co-engineering process than that you get a top-down, and this is what should be, just produce it. So, and we really try to do that. I know it's very scary for our customers because, they're afraid of locked-in. They're afraid of that we're, making sure that they cannot do it without us. But at the same time, this is the only way how you can bridge that gap between the DFMEA and the PFMEA, because if you're just asking us to produce something and the flaw is in the design, you have to have that conversation really upfront. So we really like early involvement, and we're fully committed to that.
Well, thank you, Jan.